Comparison of byte literals in Python. The following question arose because I was trying to use byte strings as dictionary keys and bytes values that I understood to be equal weren't being treated as equal. Why doesn't the following Python code compare equal? Aren't these two equivalent representations of the same binary data? The example is knowingly chosen to avoid endianness. I know the following evaluates true, demonstrating the equivalence. But why does Python force me to know the representation? Is it related to endianness? Is there some easy way to force these to compare equivalent other than converting them all to, for example, hexadecimal literals? Is there a transparent and clear method to move between all representations in a, somewhat, platform-independent way? Or am I asking too much? Say I want to actually index a dictionary using 8 bits in the form b'0b11111111, then why does Python expand it to 10 bytes and how do I prevent that? This is a smaller piece of a large tree data structure, and expanding my indexing by a factor of 80 seems like a huge waste of memory.
Bytes can represent any number of things. Python cannot and will not guess at what your bytes might encode. For example, int b'(b'1111111134) is also a valid interpretation, but that interpretation is not equal to hex ff. The number of interpretations, in fact, is endless. The bytes could represent a series of ASCII code points, or image colors, or musical notes. Until you explicitly apply an interpretation, the bytes object consists just of the sequence of values in the range 0 to 255, and the textual representation of those bytes use ASCII if so representable as printable text. Those byte sequences are not equal. If you want to interpret these sequences explicitly as integer literals, then use as.literal_eval to interpret decoded text values. Always normalize first before comparison.
b'0b11111111 consists of 10 bytes, whereas b'0xff consists of 4 bytes. Clearly, they are not the same objects. Python values explicitness. Explicit is better than implicit. It does not assume that b'0b11111111 is necessarily the binary representation of an integer. It's just a string of bytes. How you choose to interpret it must be explicitly stated.
It seems that what you were trying to do is get a byte string representing the value 0b11111111, or 255. This is not what b'0b11111111 does, that actually stands for a byte string representing the character, Unicode, string 0b11111111. What you want would be written as b''xff. You can check that it is actually 1 byte, len b''xff equals 1. To convert a Python into a binary representation, you can use the C types library. You need to choose one of the C integer types, for example.
If you want to see more, please consider subscribing.